I am a data scientist at Bark. It is a subscription service that provides dog toys and treats on a monthly basis. We provide very fun and weird toys and treats. This past month, because it was October, we had a Halloween theme, so it was Franken toys, which were toys that you could stick together in different ways and they create different weird things, almost like that scene from Toy Story 1 with Sid with all those weird things they put together. Not as gruesome, but fun, I think. So before that, I spent about a decade in healthcare, and so it's a very different switch for me. And so I'm really enjoying working with Bark and dogs instead of working with patients. It's a lot more fun. Yeah. So today we're talking about, and we're hiring. So right now I think we only have data analyst positions, but in Q1 we're going to have more of the data scientist positions just because we do most of our business, and Q4 is kind of crazy for us, and so we tend not to hire in Q4 so much. But Q1 we'll be ramping up our hiring practices again. So if you go to the GitHub page, you'll get something like this. You can just hit this open and collab, which we'll be doing together. Let's see if this wants to work. Okay. So this is Hacking the Data Science Challenge. So this is, when I was in healthcare, we had a lot of people applying for our data science positions, and I would go through, and for a while we did have these data science challenges. I mean, my personal opinion is I'm not really in favor of them anymore. People still do give them. And so now, just even if you don't like them, you still have to do them. And so I want to go through 4 aspects of them, which I find that people tend to have the most trouble with, and how to actually do them in a way that's more, or it's just a better way of doing them, or at least in my view is a better way. So take everything I say with a grain of salt. This is all based on personal experience through probably around 200 to 300 challenges that I've evaluated. Yeah. So what I'm looking at over here is we're looking at the City Bike data set. So this is a data set that's freely available and downloadable for City Bike. Is anyone not familiar with City Bike? Great, so you're all familiar with City Bike, right? You take a bike for it up to 30 or 45 minutes, depending on whether or not you have a subscription, and then you put it back in a bike stand. So the data you're able to pull from the website is duration, start time and date, stop time and date, the station names, the ID, the latitude, longitude, the bike ID, what type of user they are, what's their gender, what's their year of birth. And you do this for every single trip going back a couple of years. So it's a lot of data relatively quickly. So hopefully, let's see, let's connect. It's going to allocate. So in theory, we're going to. Oh, yeah, but anyways, I know.
We only know gender and age if they're a subscriber?
I would assume so. You can check, right? It's a nice thing about this. We'll find out. So this is just running everything. So it's just downloading everything now. Although I don't think I'm going to be running most of the code over here. But yeah. So the first part is working with trick data. So people who create these data sets are sometimes creating bad data for you, because they want to simulate what data will look like in the real world. However, the things I've seen people do, you literally have to manually go in and screw over the data in order to make it happen that way, because it never happens that way naturally, but they still do it. So one thing, you never want to take the data for what it is. So you always want to question the data. So one of the variables that you loaded in the beginning was this df data. So your task in the first part, so we're going to be doing 4 things. So for the first one we're going to be talking about is this finding trick data. So in this df data, your task is to find all the different problems with it. So some of them are just natural to the data. This is how the data came. There are some issues with it. And most of them are things that I created. So there are about 12 different problems with the data. And so I would say, what's an interesting way of doing this? Why don't we spend the next 10 minutes, everybody can hopefully maybe find someone, if you want to work by yourself, you're welcome to, but maybe find a partner to work with or 2, and really try to find what the problems in the data are. See if you can spot them. Hopefully I'll be able to pull up a list of what they are. Yeah. And let me know if you have any questions. Right.
Yeah, but it's one, but I know what happened in this step. It's just show nothing.
So if I remember correctly, there's at least 10, maybe 12 different issues I put in the data, or so. But there's a couple. That's my point. Let's keep going. Those are things I try to do everything I can think of. So. Yeah. Actually, let me see if I can do it this way. Hold on a second. So for anyone who arrived late, if you just go to this, if you go to the what's it called, this talk on the PyData schedule website, it has a link to the repo, which you can then to get here. That's easier too. So for anyone who just at the top of the page, it tells you what each of this is from their website. It just tells you what each of the variables are. So like trip duration is in seconds, user type is customer or subscriber, gender 0, 1, or 2. So those are not like errors. This is what you're given. So like yeah, a gender of 0, that's just unknown because you don't always have a gender. But yeah, keep going.
start point will be further. You can just find which one is
One is, excuse me, if you look at it, like this is roughly. So they are. I mean, like unit is right here, right? And you have some negative on 40. That means.
I mean, our the ultimate random that they
Yeah, all that should be right because one or two is these values should. Yeah.
Okay. So we've got 15 minutes. So I don't want to, so as incentives for swag, there are stickers from work. So they have fun sayings on them. Every day is a second chance to pee on something. The world is my dog park. You're just living in it. Have a great Dane. And we have one mutts are my mantra sticker. So contributors get stickers, right? So who wants to tell me, and just remember if you contributed, and I'll give you after because it's going to, otherwise it'll take quite a while to go back and forth giving people stickers. So who wants to, what are issues that people found? Yeah.
So in the bike names, we found one is named Grover, and one looks like 1010, but it's actually L0L0.
Mm-hmm. So I'm going to go back to my cheat sheet of things I actually did so I can check them off. Yes, so we have Grover, it's not a bike, right? So we have some of the, these are the bike IDs, right?
Yeah,
Bike IDs, right? Not all were numbers. Okay. What else? Yeah.
the drop-off location is roughly the same range except for like 100,000, which is the Hudson River.
Yes, all right, right. Say it again?
The drop-off locations are in a reasonably continuous range of numbers.
Mm-hmm.
And then there's one massive outlier.
Yes. Yes.
That's
So,
called the Hudson River.
yes, because it definitely is that. That was the, right. There's one, but there is, and fun fact, there is no bike station in the Hudson River, right? So, and if you check, actually, and it matches the latitude and longitude match. So it actually is in the Hudson River, but that's not a real location. That one was one of the trick ones. I'm surprised someone found that one. Great.
Ask Captain Sully.
Yeah. Yeah. Yes. Not mine though. That was in the data set itself. I did not do that one. But yes, that's an interesting thing in the data. So you'll see. Yeah. What else?
Someone had the gender code of 12.
Yes. So right. There's 0, 1, and 2, and it's fine if lots of people, but when one person has something and no one else has that, that's probably a mistake.
The time is stored as object, they're not stored as time.
Right. But why are they stored as objects? Right, because if you try to do like to date time, right? If you did, so it's df data dot start time, or actually you have to so it's pd dot to date time. Who wants to do this? Right, and I tried this. It shouldn't work. There should be errors.
It's on the stop time.
I was on the stop time. Stop time? Yeah. Some of these are invalid date times. So yeah, so some of them are just invalid, right, they're invalid stop times. What I put the times as? They're just like not, what did I put it as? Yeah, they're just invalid time. They're just, they cannot exist. I think, what was it? It was, I think, yeah, like February 30th or something like that. So, right, so in there, it looks like, and it formats correctly, but this will give you the error. So there are different ways of getting around that, but yeah.
Negative trip duration.
Right, negative trip duration. How would you go about fixing that?
Find trip duration less than 0 and then
Sure, that's a way of getting rid of it, but what else could you do? Well, yeah, so I heard someone say something over here. You could recalculate them, yeah, right, because you have the start time and the end time. You should check to make sure, because they give you both start time and end time, and then in theory, trip duration is calculated from that. So, sure, negatives are a quick way to be like, oh, that's obviously wrong, but then you can regenerate them, assuming you believe the start and the stop times.
So the end times were before the start time.
Yes, which is probably impossible, maybe possible, but probably impossible, yeah. So that was one of mine.
The maximum trip duration is 1 million. It's a possible outlier.
Yeah, so that's an outlier, but once again, that wasn't one of mine. That was so the theory, because there are, like, usually there are some trip durations which are ridiculously long. I'm not sure what that is, because in theory, if you just forget to put, to take the bike out, I guess, and never return it, it's gonna, I guess they don't have a way in the system to just say that bike is lost. So I guess they just keep putting it out. But then it does have, you'll see, they will still have a end time and an end, because in theory, if they never finish the trip, they shouldn't have an end station, but they do. So it's weird. So I'm not sure what that means, but that's a problem with the data. It's not a problem from, I did not put that problem in there, but yes, that's a problem with the data.
birth year has 1885 and 12.
Yes. So those are It definitely outliers, and so that's the problem when you let people put whatever they want in. People put whatever they want in. Anyone else? Anything else that people found?
There's some end stations that are not nans.
Right. And did anyone else find anything weird about the stations?
There's a missing.
What?
The station ID are missing, like some of it.
Some of them are missing, sure. Some of the station names.
It was the same.
Well, the station name could be well, what do you mean the same?
As in like, well, I'll get back to you.
Okay. So you'll see, right? So, hold on. Where's my mouse? So we do here, right? So we have df data dot station name. Let's see. Let's say it was star station name. Let's go with that. Yeah, star station name, right? So we can check if they're null. We're actually definitely NA, right? And this tells us that there's 114 nulls. Okay. But, and I've seen this in multiple tests, like, there also could be something like, hold on. Oop. What did I put it as? Yeah. It's equal to none, but it's a string none. Right? So that's an invalid station name, but it's read as a string, not as an NA. And so, right, it's a problem. Or when you're stuff like, oh, I guess I didn't have to put this in there? Yeah, I thought I had them. There you go. Or, yeah. I thought I put empty strings in there. There should be some empty strings. I might have taken them out. But also those are problematic. So you have to be careful about those as well. Maybe I didn't put them in. Okay, I guess they don't exist anymore. I guess I took them out. But yeah, so they're supposed to be empty strings, and in addition to obviously the null values, which are just, they exist, because those are, the null values are original in the data. I added the nuns and well, in theory I added the empty strings, I guess. I didn't add the empty strings. Anything else people found? Let's see, so right, we have negative trip durations. Oh, so trip durations don't always match the start and stop times. So that was also one of them. I switched the start and stop times. That the start time was the exact same as the stop time. So it's not beforehand, but it's the exact same time. And it's only for station, so in theory that's possible, but if they're not the same station ID, that's impossible, right? For the same station ID, in theory it's possible because you could literally do it in a second. But no, we had invalid stop times, move some of them into the Hudson. I changed some of the station names to various versions of null. Oh, and this was another weird one. Their same bike is in multiple locations at the same time. So you have to, once again, not all these were meant to find. I just tried to make some like really hard ones. So yeah, it's the same ID and the same time, but in completely different locations, right? Right, and some of the bike IDs were Grover or right, like L0s, L0, and L1s. I traded that one, and then one person had a different gender category. Great. So if nothing else, that should have given you a good appreciation of what the data is actually like. So that's a small sample of the data. That's the DF data. The actual data is DFCB, which should also be located, which also should be in your memory at this point. So what I want you to do now is, now that in theory you have some idea of what the data is, let's work on creating an outline. And this feels very like college essay-ish, and it is, but it's a problem. Because I feel like people jump into these data challenges straight into the code. They'll spend 20 hours on their EDA. They'll have nothing to show for it besides for some really pretty plots. And to be honest, I've done this myself. And then they'll spend, let's say, 2 minutes on the modeling. And then, surprisingly, the person reviewing it is not happy with it because there's no real story involved. And that's one thing I really want you to take away, is that a data science challenge, and pretty much any type of this thing, because a data science challenge is very artificial, but you will always have to do stuff like this as a data scientist, as an analyst, for work all the time. You have to tell a story with what you're presenting. So what you're giving back should be a story. It should have a beginning, a middle, and an end, and should be a compelling story. And so that's why you should always create an outline for anything you're going to do, especially when it comes to these challenges. So here's the challenge, right? Using the city bike data set, predict how long a ride will be given the information available when the rider starts their ride. And so they will say you should spend about 5 hours working on this challenge. Please make sure to include clear data analysis and visualization, well-documented and interpretable code, appropriate use of statistical machine learning modules, and explanation of the results. So this is, in theory, this is the made-up task that I'm giving you. So I'm actually not going to do most of this task, but for the first thing, what I want you to do now is write an outline for this. So over here are the 4 categories. There's going to be an EDA section, a data relationship section, a modeling section, and a results summary section. What I want you to do is now write, for each one of these, what you plan on doing in that section. So this should take you about 5-10 minutes and just write, okay, for the EDA, we're going to make this plot and this plot and this plot. So the full data set is the exact same variables, but there's just a lot more of the data, and it's cleaner to some degree. So I want you to do EDA, data relationships, so that's between different variables, modeling, like what model you're going to choose, and then the result summary of how you're going to explain the model. And so what I want you to do for each one of these is write probably about a paragraph, not more than a paragraph for each one, and also give a time estimate. So you have 5 hours. I would say try to have your time add up to 4 hours. For like, you're just going to, let's say, EDA will take me an hour, modeling will take me an hour, and all this stuff will take me a different amount of time. So have that add up to about 4 hours, 4 hours and change. And that should be your good estimate to start off with. So once you go with your partner, just go into it and into the discussion and just figure out what you want in these different sections. And then we'll come back in about 10 minutes.
Also, like seasonal variables?
Yeah.
Like from the palms?
Yeah, maybe if you can get like which time.
So like,
if you use like winter, also I think I don't like to use the calculator. I think we use this type pure subscribe or understand we have to start from the start for stable tree. Yeah, the difference between the start line and the start line. Yeah. That's good, yeah. No, it's fine. I mean, additional features. So I just starting point, ending point, maybe people use something like
Yeah, it's
scatter, scatter plot. So
I would say like you can calculate the volume.
how long am I?
I mean the
Yes, so like the dot on the left.
yeah. With different colors.
Yeah, exactly.
Yeah, yeah.
Also think it's,
So for example, like we get because time
Because on this data set, we can't,
it's just because though we're larger.
like, I guess you could,
yeah, I would say like, yeah, so
So you mean so we should first group by customer ID, whether it's a customer ID. So we usually don't see the person ID.
No, not by
I mean, then also there's canvas profile.
Yes, of course.
Yeah, that's what
Hey, sure.
Yeah, man, I think I've heard oh, the other thing too, like, like a unique app of like a ball, like say, like yeah, right. Or think about stations or like modern food.
also this user ID
and then also,
So there's like a geopod.
Maybe also provide the gender.
Oh, yeah.
I would say that
I think it's better to provide it after the
Yeah. So you only want to figure out what happens with the
call I can make.
Maybe that doesn't matter actually as much.
Yeah, right, I already know.
Like they probably already calculated this.
Yeah, because obviously we know like where you're going, that's going to be out the quality. If you don't know where you're going, probably like, you have to
They probably look at the duration for given
guess
point.
how
And they say, but they probably like, they might do station.
How about to
No, tell me this is right.
apply safe harbor
I'm
stars?
sorry. This is actually over here.
On average, these stations
Resources?
are in this.
I mean the number of passengers. Since we
Well,
need
that's the
to
thing,
make some allocation,
The construction.
we only have to
immediate information.
make some fixation and
That
allocate this.
would definitely show that relationship that like sunny weather versus rain versus
Yeah.
we do know all two grades.
This one, except for this, two score. You don't use it at two score.
The station is subway station or the
It will be, yeah. So well, I guess that would be in the modeling section.
So for the same station ID, the location is always the same. And the name is to be over.
Well, I guess, yeah, the city is different.
Right. Yeah, I think that would be like a bit like let's say,
Oh, this one
I mean, I guess you hopefully like we can
Say, time of day.
what's the difference between
our
so
expanding.
a substrate means we buy something like a box
Yeah.
I would think that
Okay, let's see, let's turn this back on. Let's come back together. So does anyone want to share, so hopefully you were not looking at what I was writing because I was trying to write ridiculous things on purpose. Like histogram of bike IDs, it's real helpful. Anyone want to share what they did for, what their plan is for EDA just in terms of the time and the type of things they want to plot? Sure.
Yes, we were thinking like maybe like bucketing by time of day, like a heat map of like start and end stations, like the magnitude.
Mhm.
Seeing like these are popular commuting destinations at like certain parts of the day.
Okay.
My lab is going to enrich it with sunrise and sunset times, so therefore say night versus day, because that compares humanity, or am I forced to only use just this data set that I have?
So that's a great question. That's something I was gonna, if wasn't brought up, I was gonna discuss at the end. So in general, they will usually be very specific if they do not want you to use external data sets. If you want to use an external data set and it was not mentioned one way or the other, always ask questions. Be like, do you mind if I use this data set, right? Because in addition to that, maybe weather. Like if it rains, maybe that's important. Or snow, yeah. And I would assume it is. And I can show you that later where I'm pretty sure it is. But that's not in this data set. And so that probably is very predictive. And so you'd want to, in a real data science, like if you're doing this for work, obviously you'd pull the data in because why wouldn't you? But for a challenge, sometimes they do not want you to use external data for a variety of reasons. So it never hurts to ask.
Can we use gender, or are we getting into a whole issue there of that could be biased, or are we affecting people based on that? What would be the outcome to the user based on the result of this model?
So that's a great question also. And that's, for a data science challenge, I would use whatever you have. I would not really so much, unless it's really, really ethically like unsound. Like using gender to predict ride length doesn't sound like it's possible to use that for evil purposes, but it isn't inherently a bad thing, right? So I wouldn't really worry about that. But for this, I would, yeah, unless it's something that really like it feels wrong to use, there's no reason not to use it.
One plot idea was like average duration broken down by month. Yeah, just based, I mean, because not considering weather, I think you have a general sense of what New York weather is like in December as opposed to April. So.
Right. So that's a great thing. Yeah, so you have that, right? That's a great plot. Anyone else?
Average duration by start station ID. So giving a starting point, what's the average duration that people take starting from there?
Sure. That's yeah. So that's yes. The problem. Yeah, that's interesting.
That would be a good baseline model. It's very simple.
Yeah.
Maybe try and like display like some of like the station like latitude, longitude, like a map of New York City and do like a density.
Right. So I mean, so two things. One, you're getting into the data relationships, which is great. We could definitely jump into those as well. Two, that's something that like be aware of like how long it will take you to make a certain kind of plot. So that plot, especially if you're really not up on geoplotting, that's going to take you a couple hours by itself to get that actually to work and be nice. Because remember, everything at the end, and we'll come back to this because the next section is going to be actually creating one of these or a couple of these plots. You have to be realistic in what you can do in the time frame you have. Like they say 5 hours, and like a lot of people say, oh, just ignore that 5 hours. I would say no, try to do what you can in 5 hours, and then if you have time, come back and do more. So think what you can actually reasonably do in 5 hours, because in a business case, you will have a limited time. You will have, let's say, a week to do a project or some X amount of time to do a project. You cannot be like, well, you cannot ask for more time simply because you want to do a prettier plot, right? So understand how long it'll take you to do things when you're setting out doing them. This is why I want to have this outline, because that's a great first inclination. That's a really interesting plot. But if it takes you 5 hours to do it, you've spent all your time on something, on one thing, and they're going to be like, great. I'm going to take the person who actually built the model instead. Right? But yeah, so I don't know this way. That was a great idea for a plot, but just keep that in mind. Anyone else in terms of the data relationships also that anything that they were thinking of doing that was different or interesting or standard?
User type, sorry.
Yeah.
User types would be important. The different user types may have different patterns of writing. The subscriber will use it more.
So does anyone here use CityBike? So, right, and so here's where a little domain knowledge is going to help you. What can anyone who uses CityBike can tell me the difference between a subscriber and a non-subscriber?
So subscribers, I think, get 15 minutes extra.
Yes.
Have to check in the
Right. So if you're a subscriber, you get 45 minutes per ride. If you're a non-subscriber, you only get 30 minutes before they charge you more. So that's an interesting, right? It'll definitely make a difference because you'll see that like there's tons of rides that end like 30 to 40 to 50 minutes or like 40, like around that time, specifically because they get charged more. So that's where like, so for City Bike, you can find this domain knowledge, but like if you come in with your own domain knowledge, even just a small piece of information can really help you. And so usually they will not expect you to know that coming in, especially because, I mean, City Bike, in theory, it's well known enough, but for something more esoteric, like marketing or something like that, you shouldn't be expected to, but if you know it, show that you know it. Like, because it never hurts to show domain knowledge.
The standard, use the one to create hair plots, just randomly look at all the input variables that are available, and use some correlation to see anything jumps out, create some histograms, just as many variables as possible, see if any relationship jumps out.
Right. And so what I will say to that is that's a great inclination and a great way to, at the end of the day, I'm going to repeat this a couple times because I think it's important. It's meant to be a story. So definitely if they're very quick plots to do, make them and then delete all the uninteresting ones from your actual report, right? Because you don't no one wants to see 50 histograms. That's just not interesting things to see. You can write a line like, obviously if you're showing 3 histograms that are interesting, I will assume you did all the ones and are showing me only the interesting results, right? And if nothing's interesting, you could write the histograms were not interesting, or throw a throwaway line in there so they know you looked at them, and assuming they actually are not interesting. Like if there's something, like don't miss something, don't assume there's nothing there, and just write something about it. 'Cause that's obviously much worse if there's something there and you just said, oh, there is nothing there. But yeah, definitely. Once again, it's a story, so it should be as short or as long as it needs to be.
I have a question about that. So if the challenge asks you explain your thought process, and part of my thought process is let's just look at all the data, make a correlation matrix, make all the histograms. That's part of my thought process. So my initial idea would be I have to include it because it was part of it. But what you are saying is highlight what was important, so maybe put that in an appendix or something?
Well, no, if it's not, I would say you can write that, like, I looked at the histograms and I'm only showing you the ones that were interesting, right? Like, it's not like a math test, right, where you have to show your effort. If it's uninteresting and you wouldn't present it, like, really think of this as a story. If you would not present this in a story, don't present it here. You can definitely write the line that, here's what I did this and this because of X, Y, and Z, right? So I chose these 3 histograms because they had interesting data, which is why I'm displaying them. That's a valid way of doing it, and that shows not only did you look at the data, but you then thought about the data that was actually interesting. Because nothing's worse than you sending me something that's like 300 line or whatever, like 300 cells long of like every single possible thing you could possibly plot. You're just throwing the kitchen sink at something. A report, think about a report, like it should be 1 to 2, right? Or think like, once again, going back to this college essay analogy, 1 to 2 to 3 pages long is how long the report should be. Someone should be able to read your report in 5 minutes or less and get what you're saying, right? Not run the code, but they should be able to like just run through it in 5 minutes, and it should be cohesive, it should tell a single story, and it should like build up to something. So that's the way I want you to think about, or that's the way I think about them, and when I see those kind of reports, it just makes sense. And also think about the report you'd want to see. Sure, you know all these techniques, and you really want to show that you know all of them, but right, it's more impressive if you always show that you know which one to use in the right case. I find that much more interesting than showing me you can do everything. Showing me that you know not only that you can do everything, or that you know the right thing to do is a much more interesting and it's a much rarer skill. Yeah.
I guess like plotting distributions of variables to see if there's anything you need to account for, say if it's like a non-linear, or like, when you took your pad to
Yeah.
run the model.
Right, that's a great thing also. Anyone want to talk about what kind of model they would use? So this was meant to be a joke. And I'm going to say this, I'm going to repeat this a lot. If you use a neural network as your first model, I am not going to read the rest of your thing. Because especially for this data set, like, why are you using a neural network? In general, like, unless the company you're applying to is like, neural networks are us, don't create a neural network. Because like, they're pretty much unexplainable. I know there's SHAP, I know there's Lime, no one ever can use them correctly. They make no sense to anyone who doesn't really understand them. Like, they're not helpful for the average person. Especially if you're presenting this to people who are not data scientists, they will have no idea what you're talking about. The caveat being, and this is not for a data science challenge, in certain companies you do have to do them because it makes everyone very happy when you do a neural network, even if it's not the right test. But that's a very specific use case, not what we're talking about here. Here we're talking about something where you're giving it to someone who in theory knows what they're talking about, and if they see a neural network, they will not care. Mind you, if you really think it's the perfect model, do it as your second model. Show them that you can do something besides for a neural network. But yeah, so I know you haven't touched the data really at all. I mean, besides for looking at the trick data. Anyone have ideas of what kind of model they would want to run for this?
Linear regression.
That's a perfectly valid one. Anything else?
Random forest.
Random forest. Anyone else?
Just standard ones to just run in logistic regression,
Yeah, logistic regression. Remember, you can also, yeah.
especially subscriber and non-subscriber.
Yeah, and so you can also do stuff like, they were very, I try to be relatively vague on the task, like the writing time, because like, they give you writing time in seconds, but you can maybe think about, maybe you want to actually do it in minutes or, you know, hours or stuff like that. Or let's say below 15 minutes or after 15 minutes, like you just want to, because it probably doesn't matter if they're a 5 or a 4 minute ride. It matters if they're a 5-minute ride or a 45-minute ride probably. And these are all different, this is how you want to think about these tasks. Like what makes sense for me to do? What's an interesting way of approaching the data that's still in the realm of what they're asking for? And then for the result summary, I mean, so this is much harder to do at this point, and this is why it's going to be vague. It's going to be, so you're going to have some kind of plots and analyses for the most part. But this is, I wanted to put this here because people always forget to do a result summary. They will do a results, they will give me something, and then maybe they'll throw an F1 score. I don't really care. Like, that's not explaining the results. All you've done is, right, think about this, like, you ever see a TV show or a movie, right, and like all the actions, they have that huge action scene? The action scene is not the last scene in the movie, right? There's usually a couple scenes after where everything cools down and they have this sit by the fireside or they go out for shawarma or something like that, right? And that's what your result summary is meant to do. It's meant to bring everything back and be like, here's what we found, here's why it made sense, here's why it didn't make sense, here's the problem with what it is, here's what I do if I had more time, which is always a great, because that's always a great way also. Like if something you think is really interesting but you don't have time, you can say, here's what I would do if I had more time. So it shows that you thought about these things and you were going to do it, and you would do it, but you were cognizant of how much time it would take. And so you're able to get credit for not doing something, which is the best kind of credit to get, right? Just saying you're going to do it and you get credit for it, oh, what's better? So what type of analyses do you think you would want to do for this? Given, because I mean, spoiler, what I'm going to give you at the end of this is I'm going to give you for the last task, we're actually going to be doing result summary. I'm going to give you predictions. Just going to give you the predictions and the results. I mean, sorry, the predictions and the actual durations. And you're going to have 2 sets of data. So how would you want to actually, what would you want to do with that?
Where does my model work better? Where does it need more room for? What are the trends for where it works and where it doesn't?
That's a great thing. What else?
Do you want to see how accurate it is and also how well it differentiates?
Right. Right. So you can see there's like, and this is probably the hardest thing to do at this point because I haven't told you what you were getting, but that's what you want to be thinking as these things is the prediction and the results of the model is just the first step. You then have to then finish the story and tell me what it means and what I can use it for. And even if it's a bad model, if you tell me, okay, it's a bad model, we should go something simpler, more complicated, or something, just tell me a story, right? Or like, to be continued in part 2. That'd be interesting, right? And like if I had and then they'll bring you in and they'll ask what you would do next kind of thing. Like lead them on, make them interested in what you're saying. Okay, so we've done this, right, modeling part of it. I mean this outline. So now you have an outline of how long things should take. So now let's do some EDA and data relationships. So based on the above outline, create at least one figure from both the EDA and data relationship sections. So it doesn't have to be the ones you actually wrote. If you heard what other people said and you thought, hey, that was a great idea, steal their plot. Perfectly fine. Because I bet you're probably going to do it in a slightly different way than they're going to do it. So each figure should be presentation ready before we move on to the next one, right? It's essential that a plot should be self-contained before you keep going to the next one, and the next one, and the next one. Just make each one as nice as it needs to be before you go on. Right? It should be as understandable as possible without any externalities, which means make your labels mean something versus just like x-axis, y-axis. Not helpful, right? Have a legend, have what's called a title. All these things are essential to plots. Is anyone who's heard of pandas profiling? Let's go with that. Okay, good. So you haven't heard of it. So I can tell you. So pandas profiling, this used to be like, I love pandas profiling. I will show you what this is. It's a package that came out. I don't know when it came out, but I found about this a couple months ago. You give it a data set. So this is the result for the city bike data set. So you give it a data set, and you say, give me a profile of it. And what it does is it outputs all of this for you. So it tells you the information, the number of variables, number of observation, how many missing, duplicates, what type of things you have, the cardinality. For each variable goes through and tells you all this information. You can toggle the details for it. You can see a histogram, right? You don't have to do a single thing of work for it. And now, did anyone find something interesting in the birth year data set yet? I mean, I'll spoil this one. But did anyone know what the default value is for birth year? Does anyone know now what the default value is for birth year? It's 1969, right? Or at least that's what I'm assuming that's what that means, right? Because there's this huge spike there for no reason. Unless it's the default value, which would make sense, right? Because it increases, but for some reason 1969 is just huge, right? So if you look at common values, right? You can see that 1969 is 10% of the people were born in 1969, 66,000. Yeah, right? Right, but they weren't born then, they were conceived then. That was the point, right? Some were 69, which means they should have been born in 70. Right, but you can see, right, like all the other years, like if you look at 1970, it's not even on this list. And 1968, 1969 is just huge. So this is pandas profiling, gives you all this, and it's no effort. It is, because originally this talks, when I first used to give it, half of it was doing these things. That's all gone now because it does it for you. And so, and do not be afraid, it gives you correlation, it gives you everything, and missing values. It's unbelievable. And it gives you samples just because why not? And it's literally 2 lines of code. The code is literally like, it's like import pandas profiling, and then pandas profiling, like give me the report, you give the data set, and it prints all this stuff out for you. It's all you have to do. It's the easiest thing in the world. So this is linked in the Colab notebook over here, and here's the link to the actual Python package for it. And so take a look at that, and don't be afraid to use that. Like, a good data scientist is someone who uses their tools. So you don't have to like pretend you don't know it exists and be like, oh, and like show how you calculate these things. You can link to the pandas profiling result and just talk about the interesting results that come out of it. You don't have to actually recreate the wheel. If someone did it for you already, you don't have to do it again, right? Like you don't have to recreate how doing arrays and data frames, right? Because pandas exists. Pandas profiling exists. You don't have to do it by yourself. You don't have to do it yourself anymore. So using pandas profiling just to get a good look at the data also. So that's why EDA is probably not going to be so important at this point. So try to figure out one or two, one EDA plot and then 1 or 2, exploratory data relationships where you're looking at 2 or more variables. And so as a guide, this is a table from Burton's Semiology of Graphics, which is a very interesting book on just graphic design. And this is actually specifically what I saw in Jake Vanderplas's, who is the author, who's the primary contributor to Altair, which is a plotting library in PyCon 2019, talking about how to think about data. But pretty much he splits data into 3 basic categories. It's quantitative, ordinal, and nominal, right? So quantitative is just your basic numerical data, 1, 2, 3, 4, 5. Ordinal is things that are ordered categorical, right? So like Likert scale is ordered categorical, or anything where the relation, like good, great, best, right? That's ordered, but it's categorical, but it's ordered. And then nominal is unordered categorical data, right? So different fruits are just unordered categorical data. And what he shows is how this table is a measure of how easy these things are to visualize using the different types. So position is great for everything. Size is great for everything. Color value is great for nominal and ordinal. It's not great for quantitative value. Texture, great for nominal, not really great for ordinal. It's garbage for quantitative. And just this is a good guide for how to think about plotting these different things. And then just for people to use, here are some different libraries and just their sample plots. So you have Matplotlib, Plotly, Seaborn, Plot9, and Altair. You pick your favorite. The data challenge is not the time to be learning a new plotting library. You should have some of these tools under your belt and just be popping them out. Because these, remember, you have a limited amount of time. You have other things you have to do with your life. Just pick something you know and use that. And so yeah, spend the next, let's say, 10, 15 minutes creating 1 EDA and 2 data relationship plots and try to make them as pretty as possible. And yeah, so go. Also, remember that I'm not mic'd in. The data you want is DFCB, not DF data. DF data was that trick data. DFCB is the actual valid data. So, right, DF, which should be loaded into memory at this point. Also, when you run those first cells, so this is the real data. So everything is, the mistakes that were inherent in the data are still inherent in here, like the 1969 stuff and the person born in 1885, but all the other weird stuff, like the negative trip duration stuff, that's all removed. Let's go with that way. Nice.
I'll have to sneeze.
Okay. Okay, in the interest of time, we're gonna, I'm still on, right? So because we have about 15 minutes left, let's run through. So, anyone want to tell me what they plotted? I mean, like, so I chose, right, so this is using Altair, which I like a lot. I strongly recommend it, something to learn, not for a data science challenge, but afterwards if you like it, because it's relatively simple, right? This is the entire code to create the plot, and it gives you nice tool tips, and you can have, it's very, and I'll show you more things you can do in a second. So what do people do for either their EDA or their other plots? Well, let's see, did anyone get through making a plot, a fully formed plot? Let's go with that. Okay, sorry. And so anyone else make a fully formed that they're happy with at this point? Okay, so you had about 10, 15 minutes. You can see, right, you can't do one figure in 10, 15 minutes. I'm not saying, and that's understandable and reasonable, and this is the point, right, that like you have to allot your time beforehand. So be aware, it's going to take you 20 to 30 minutes to make a single plot. And so if you want to make 10 plots, sure, obviously you're just making slight variations, you can do it that way, but it takes time. You get lost in the code and it's 3 hours later, that's a problem. Be aware of how long it takes you to make these things. So you have an idea of, I'm going to make 5 plots, it's going to take me an hour. Right, because you always think, I don't know, I always have this idea, oh, it takes me a couple minutes to make a plot, 5 minutes maybe. No, if you want to get the axes right, you want it to look right. I didn't get the size right or the formatting right here yet. This is really just using the base characteristics. Yeah, so anyone found anything interesting in the relationships?
So I did something simple. I just did an average of trip duration versus birth year on the x-axis.
Mm-hmm.
So it's basically constant up until people born in like 1993 or so. And so the younger people have somewhat longer trips on average. And there's an enormous spike in 1969, which makes me think that the people who don't fill in their birth year, maybe they also just forget to put their bike back or something.
Right, that's right. And so knowing how the data is tells, right, just knowing that that's also why I would not suggest making those 1969 people nans, because you want to split them out, but maybe put them as something else, right? And so that's why it's important not to just group them with, with everyone else that's missing a birth year or whatever it is. Because it tells you that they did something specific. The problem is obviously the people who were born in 1969, they get washed, but there's nothing you can do about that. But yeah, so that's interesting. Anyone else find something interesting? So anyone do anything, let's say, about weekdays versus weekends? Right, so I warned you, that's the point, right? There are hundreds of different plots you can do, so I just want to show. So hold on, when I can find wherever my mouse is, there it is. So we're going to skip. So over here I have, we'll come back to this in a second, but if you click on this link, it's an example for summaries. So here is a summary of my EDA for this thing. So I'll come back to these other parts later, but let's just scroll down and just go to the EDA. So this is me doing everything I could possibly think of. So here's, let's say, count versus trip duration, right? So you can see that. And this is plotted on a log scale, which I thought was more helpful. So you can see. Right, and so this is interactive, so it's nice. Right, so most of these people, right, tend to be, like 12 minutes, all these really times, very short durations. So we can scroll down. So I thought this is interesting. It's count and trip duration as a function of cumulative percentage of riders. So you can see that more than like, what is this? Like 12 minutes is about 60% of all people are 12 minutes or less. Right, and so you can see, so you don't have to plot a lot. And this, I think, is helpful for this kind of analysis also. So if I just told you, 12 minutes, they'll be on average 12 minutes or something like that, right? They'll probably get you most of the way there in terms of your modeling already. And this is what it's meant to do. But you can do things like this, which I think is helpful. So this is the start date and then the count. And so the orange ones are weekends and the blue ones are weekdays. And so you could see, right, so definitely, right, these weekends people don't ride, but like what happened over here, which is significantly different. I'm assuming there was raining or bad weather or was extremely hot. Something in those days, right? And so we'd want to link in weather data, right? Oh, that's interactive, yeah. Or here you have, let's say, the day of the week and the average count. Here you have hours of day, right? And the number of people who ride the bikes then, right? So you can see, right, so there's this huge spike over here, right, like 7, 8, like the commuting times. And back also, 5, 6 p.m. It's also this big spike. I'm not sure why it increases the rest of the day also. I guess these are people leaving work early. It's interesting. But yeah, you could see, so this was other analysis. This was looking for find those missing dates. We could see that certain stations are very popular, have like 40,000 uses, and some of them have like 11th Street and 43rd Avenue, like very few people use that station apparently. But yeah, so you can see right here's that birth year one, the birth year and the count of different writers. So yeah, there's this also. It's interesting. Oh. Yeah, so right, trip duration. You can also do things like calculate things. You can like do the trip distance and the trip duration. This is not helpful for predicting trip duration, but just something interesting you could plot because you'd expect it to be there to be a relationship between them. Have like trip duration versus birth year. I didn't find it to be that indicative, but you can also plot this 8 different ways. And that's the point. You want to pick 1 or 2 things you think will be the most informative and jump to those. So we have about 10 minutes left. So I'm going to skip this last section. And so here's just something you can play with on your own. So it's a model explanation and summary, because I want to give time for some questions and some other, just my musings and thoughts at the end, which actually is what I called it. So this goes back to what I was saying before. A common mistake is just to present your results with either just a score or a confusion matrix. But you want to present more than that. You really want to tell a story of a figure or two, and then why your model succeeded, where it failed, what you would do next, what are your next steps. Exactly like you were doing if this was part of your actual job. So let's get to some musings, and we'll hopefully have time for questions. So structuring your data science challenge. Once again, this comes back to it's supposed to be a story. You should always start with a summary and a README. Your summary should be pretty much the equivalent of a blurb in a book. It should be, here's the summary of what I was doing. I'm examining this data. Just here are some interesting things about it. 50, right, you can have hyperlinks to link to different figures, right? And this is in the GitHub also, so you can find all these files there. There are less writers on Sunday, and you like have nice links to it, so they can like you're telling a story over here. And then nothing really correlates to the trip duration, which you can see. And then in theory, you'd also have a section on what the results were. Like I used a linear model, and I found that it worked well for, let's say, it accounted for 80% of the data. And if I had more time, I would do a logistic regression, right? And that's a good summary. It should be a 1 paragraph or a couple paragraphs telling me exactly what you're going to do, how you're going to do it, and what you got. Then you also want to have a README, which, right? Because if the code doesn't run, I can't use it. So if it's something, especially if it's something weird about your code, first of all, it never hurts to put down what packages you're using and the dependencies just in case it does something weird. But if you're doing something weird with your code, let me know ahead of time or let the person know ahead of time. They're like, you're on Python 2.6 and it'll only work on Python 2.6 for some reason. That's fine. It's perfectly reasonable. And like if there's a good reason for it, because, it uses this package, which doesn't exist. They never upgraded to 3, whatever. That's fine. Just make it very clear. So, yes, you want to have, and I have an example, README and summary. So things to keep in mind, just like any presentation, spelling and formatting matter. If I see spelling mistakes, especially more than one, it right away turns me off of the candidate. And you should check for it. So, and there are things that do that already. There are spell checks for Jupyter Notebooks. It does automatic real-time spell checking. You also have Jupyter Black, which is a formatter, which is how you can get really pretty formatting for all your code. So you don't have to know what the actual PEP 8 rules are. It does it for you. It's really nice. So there's some other musings. So tell me a story, which I've hopefully drilled into at this point. Ask questions. If something is not clear in the challenge, ask questions. They might specifically be giving you vague instructions because they want to see if you'll ask questions, right? I mean, I haven't done that, but I definitely know friends who've done that, who give data science challenges, because they want to make sure you're able to communicate. You're able to, come back and say, hey, this makes no sense, or hey, help me with this part of the problem. Explain and justify. Don't randomly select an algorithm. Why did you choose the algorithm? Why were your choices valid and reasonable? Why did logistic regression make sense? Why did random forest make sense? And it could really be simply as it works for this kind of, like, this is the data we have. Random forest is a good model for this kind of data. This is why I used it. That's perfectly reasonable, right? What else would you try if you had more time? You're going to have to answer these questions later probably anyways. Hopefully they will ask you about the challenge and not just have you give it to them and then throw it away. Random seeds. Always set your random seeds for code reproducibility. I know that kind of defeats the whole point of random seeds, but if, especially, not that most people will not run your code, but if they run your code and it produces something completely different, they're going to call into question everything you did. And so it's nice if you just say, oh, you can always reproduce it using these random seeds. And tailor your response. So consider the job description and tailor your approach to match the skills you need for the job. If it's very heavy on an ML job, spend most of your time on the modeling. If it's a very heavy analyst job, spend most of your time on the analysis beforehand, right? Match to what you're going for. And also where you are in the company's interview process. The earlier you are, honestly, the less you really have to do. If they're using this as a screening tool, you should not be killing yourself. If they're using this as the final step to decide between you and another candidate, you should kill yourself, especially if you want the job. Like, kill yourself for that thing, right? Because there are places which will do it, and they're going to spend 3 minutes looking at it just to make sure you know how Python works, and they don't care. So if you spend 20 hours making the prettiest thing in the world, it's kind of a waste of your time, not theirs. So submit an IPython notebook and an HTML download. Python notebooks sometimes don't work. They have to send it around the company, and then someone has to start up a kernel and stuff like that. So send them an HTML file, right? So this is an HTML file of Jupyter Notebook. It shows everything. It's perfectly reasonable. It's readable. It's clean. It's easy. Do not use neural networks. We're just going to go with that one. Just don't use it. And then create a portfolio. This is a great way to build up your portfolio. Especially, you can always ask the company if they're fine with you putting the project after you're done with it on your own personal GitHub page. This is a great way to show people who come to you afterwards, who are hiring you, or you're trying to find out more about you. These shows you the range of things you're able to do. Personally, and it's more anecdotal evidence. I have no evidence. I have no actual data to back this up. But if I see something that says forked from X, I don't care about that repo, because I don't know how much work you did versus how much you just copied. And I'm not going to spend the 3 hours comparing the repos to understand, oh, you actually did significant changes to what this other person did. I assume you just copied it and used it, which is fine, but that doesn't impress me at all. Same thing with classes. If you're like, oh, I took this class, I assume you just followed the instructions and did nothing novel on your own. So I'm going to ignore those repos. So the more repos you have that are purely your code, the better it is, and the more I'm going to take a look and notice, right? Because I've seen stuff where just like class after fork, don't care about any of them. And even if you're going to do forking and do a lot of differences in the code, copy the code, don't fork, or make it very clear that like this code was inspired by this other person's thing, but don't fork it. Because forked just implies to me that A, you're going to merge it back in, especially if you're not merging it back in. Do not fork it. And so yeah, that's kind of lost my train of thought there, but yeah, so copy it, attribute to its proper source, but don't fork, because fork implies to me that this is not your code. That's what it implies, which is fine, but I'm not going to look at it when I'm trying to look at who you are as a person and as a programmer. So in terms of the grading rubric, things that matter, and I'm definitely missing things over here, and the order will change depending on who's looking at it and what they care about. So does your code run? What is the ratio of text to code? It should be a lot of text and some code in terms of like story, right? I want to see a story that takes me through every single step of the way. You want to be a very good communicator, because communication is key, right? There's an adage in academia, publish or perish. In data science, it's very much tell me a story. That's what I want to see. What is the ratio of text to code? I should not just be seeing block of code after block of code after block of code. It's uninteresting and it doesn't tell me anything. And it also doesn't tell me that you understand what you're doing, it just tells me you're able to do it. And you could have just been doing some copy pasta from Stack Overflow, which definitely happens and we all do it, but I want to know that you understand what you're doing as well. So that's why the more you write about it, the better it is. Do you explain what significant choices you made and why you made them? Are there any spelling mistakes? And is your code Pythonic? Some people care about that. I tend not to care so much. And then just at the bottom, here's just a list of good newsletters and data science articles that I tend to read like half of these a week if I can, because they just come out so frequently. But these are good. Some of them have job listings. Some of them are just interesting things to talk about. So yeah. So we have about literally a minute left. So I'm not going to make everyone stay for Q&A. So I'll happy to stay after if people have questions. Otherwise, thank you for your time.